Okay, so hello everyone. Myself Venu, lecturer in mechanical engineering from Government Polytechnic Varangal, and subject dealing is refrigeration and air conditioning. And today's video lesson on today's topic going to discuss on rotary and centrifugal compressors, and uh, this is today's lecture. So if you observe the previous video sessions, so we have concentrated on the new chapter, started a new chapter regarding the refrigeration equipment. So in that we have seen uh, what is the importance of the refrigeration equipment, and what are the types of equipment, main components involved in the refrigeration equipment. And we have seen the compressor, and listed out all the condenser and evaporator, expansion valve. And from that we have started the compressor, regarding what is a compressor, what are the different classifications. So based on different factors, we based on the two we mostly majorly we are divided into two groups. Next, further, depending on different factors, we have classified the compressors, and we discussed elaborately regarding the functioning of the reciprocating compressor. And next we have seen the hermetic type of sealed compressor. That we have seen the regarding the advantages, disadvantages, and some applications, and seen some frequently asked questions. Okay, and in this today's video class further we will discuss regarding the compressors only. uh, there are different type regarding depending on the function, how, depending on their construction, how they are differ from reciprocating compressor. So we will see in today's topic regarding the rotary and centrifugal compressors which are used in a refrigeration part. So just just recap all the what I have told. That again, the same thing, the construction and working of reciprocating compressors and hermetically sealed compressors. So in that we have seen different subtopics regarding that. And in this today's class, so after the completion of this period, this video lesson, so you would be able to understood, and regarding after completion of the class, a little information regarding what are the types of a rotary compressors. Actually, what is a rotary compressor, what are the different types, and we'll explain the different types of rotary compressors. We'll see the construction of that, how they are making functioning, and how they are compressing the refrigerant which is entering into the rotary pump. And just we explain, we'll see small line diagrams of both the compressors, and we'll see the centrifugal compressor working also, how they get at what case we are using these centrifugal compressors in the refrigeration part. So we'll see all the things here. Next, coming to the starting of the topic, that is the rotary compressor. So it itself, if you observe in the previous case, like a reciprocating compressor, so name itself indicates whatever the components we are utilized in that compressor, in the reciprocating compressor. Why the name has given like that means a piston cylinder arrangements are there where the piston is getting reciprocated. So to and fro motion will be there, or reciprocating motion is obtained by the piston in the cylinder. So the name is given like that. In the same similar case, rotary compressor means, so it utilizes some rotating member. So in place of piston is reciprocating, in place of piston a rotating member is utilized here. So that rotating member is utilized to compress the fluid within the section. So that type of cases you can consider as a rotary compressors. There may be a different types of rotary compressors are available, and why it can be chosen when compared to the reciprocating compressors. They are very less noisy in operation. Instead of that reciprocating motion, there will be a lot of noise is created there, and it requires more the lubrication in that. So here, due to its rotating component, may be very less noise in operation, and it possesses a very high volumetric efficiency compared to the reciprocating compressors. So due to negligible clearance, whereas you can see some clearance volume is present in the reciprocating compressor. where it doesn't requires, it is a negligible clearance here in this rotary compressor, and that is the reason why it has high volumetric efficiency. Next, classification of rotary compressors. So they may be classified as the first one you can take it as a roller type compressor, and vane type compressors, and screw compressors. Next you can take it as centrifugal compressors. So these are the classified one: roller type, vane type, screw type. And centrifugal is a different case, but they may considered under this here this classification. So remember these types or these classifications: roller type, vane type, and screw compressors, centrifugal compressor. The name itself, it is indicating roller, in the sense a roller type of structure can be used in these type of compressor. We will see that line diagram, then you will get some idea regarding this compressor. And vane type compressor means vanes are used here, just like some blade type of structure, vanes, and we will see the construction. And screw type, in this, the screw how coming, just like a threading can be seen on that. So at different cases, these screw compressors, when the screw is rotating, it gives some translatory motion. When the screw is rotating, rotational motion is taken into the translatory motion. So utilizing this concept, the whatever the refrigerant is entering into that, it may get get compressed by changing its section at different cases. It may get compressed. So centrifugal compressors means depending on the principle of using the centrifugal force. So we will see what are the components involved in that. If you see the line diagram, you can clearly understood all these compressors. So just look at the first case, that is this is the diagram, roller type compressor. Okay, so now, so you can see the diagram here. This is a roller type compressor, and you can see here, right? So this is a roller. So whatever the section, this one, this is a cylinder, this is a bigger one, in inner section, bigger one, this is a cylinder. So to the cylinder, you can see a suction port is connected, and here there is a delivery or a discharge port is connected here, a suction port and a delivery port. Suction port and a delivery port is connected. So at the center you can see a spring arrangement along with one blade is provided here. Spring arrangement along with one blade. We'll see what is the importance of all these things. First look at all the components involved in this. Now this is the roller. So roller is rotating inside the cylinder. Roller is rotating inside the circular cylinder, and you can see at the center there is a shaft. Okay, at the center is a shaft, and this roller is rotating like in a eccentric way. It means it's not rotating about its center axis. By here it is taking the reference of making contact with the center shaft, and it is rotating here, where the what are the gap provided in between at different cases, it will be a different one. It is not exactly rotating at the center. So since it is a rotating like eccentric part, so different cross section can be seen inside the different section can be obtained. Now around the cylinder you can see here you can see some lubricating oil is provided here, and below that you can see it is completely dipped in a lubricating oil, and at the top you can see a high pressure. So there is a discharge port here. So after compression, the high pressure gas is coming out, and this high pressure gas through this port you can see this connection is making to the condenser. So main components, that is this inner round part, bigger one is a cylinder, and the inner one is a roller, and at the center you can see the shaft. So it is a constructed like eccentric part, and this spring along with the blade is connected here, and two ports, suction and discharge port. So oil is present around the cylinder, and above that a small gap is provided where the high pressure gas or high pressure refrigerant is is accumulated at the top, and that accumulated refrigerant will be sent to the condenser through another port. And here through the suction port, refrigerant from evaporator is entering into through the suction port. So here you can see spring along with the dividing blade, and at this suction port you can see the low pressure refrigerant is entering through the suction port. So all these are the components so included in the roller type of compressor. So remember, just you can have the diagram of this particular thing. We'll see the next case regarding after this roller type compressor. Just we will see the working. So just have a look here. 4 different diagrams is provided here. Just I will give a brief explanation here. Again the same case, so elaborately you can see here. So at the from left you can observe there is a blade spring along with the blade, so it is always making contact with the roller, or you can name it as a impeller also, making contact with the impeller or roller. And at this center is the rotor shaft, and here around that roller you can see that outer portion can be taken as a cylinder. So to the cylinder, what I have told, the 2 ports are connected. One is the suction port, and you can see at this side, at the top left side, you can see there is a discharge port. Okay, now the whenever this roller is making rotation, now consider this first part 1A, this first diagram A. What happening here? Consider that suction has taken place. Now the roller is making rotation clockwise direction. You can see the second diagram here. Now see, the roller is making contact at the bottom of the cylinder. What happening here? At one side, a slight opening of the suction port is taking place, and at other side, whatever the vapor refrigerant, low pressure vapor refrigerant is there, is getting compressed at other side. Means it is pushing the whatever the volume is there, it is decreasing at the side, and it is making pressurized in the right side of the you can say right side of the roller. Here see the shaft or whatever the shaft is there, rotor shaft, it is at the center exactly. So eccentrically it is rotating, making contact with the cylinder at a point. Suction is happening simultaneously if you observe the second diagram. Now what happening here? So during its complete rotation, you can observe the blade in the second diagram here, spring along with the blade, it is making contact with the roller. I think you got some idea regarding here. In the first diagram, it is making contact here. Whenever the roller is moving from one place to other place, it is also making contact with the roller at every time. So what is the importance with this spring and blade? If you are not placing any blade here, there is no use of this whatever the working is happening here. The suction of the refrigerant is happen, and it will direct enters into the discharge part. If you are not using this blade or spring along with the blade, so it will separate these two sections, the suction side and the discharge side will be separated with the help of this spring blade arrangement. Now you can observe the complete opening of suction port is taken place. So at simultaneous operation is taking place, the suction is happening at other side, and you can see the roller is trying to push the refrigerant at other side of the at the top. You can see, so complete the pressurizing of the refrigerant is taking place, and it will be pushed through the discharge port. You can see complete compression is taking place at other side. You can see in the C and D diagrams how the roller is changing its position from at the left side to up to the top side. It is moving again, it is coming making contact at the left side. So complete the complete movement of refrigerant is taken place through the discharge after compression. So this discharge port is connected to the condenser part. Every time must and should the spring and blade has to make contact with the roller. Now here the suction is taking place at the left side. Okay. So this is the regarding these 4 diagrams. So these are very important to describe the working of roller type compressors. So kindly note this diagram. This is very important. Next, just we see, just we list out. I hope you have understood that working principle. Just I will list out all the points written here. Then you can notify, or you can consider, or you can write a notes regarding by considering all these points. What are the same points again? We will describe here. So it consists of a cylinder. It consists of a cylinder, a roller mounted eccentrically on motor shaft. Explained what is eccentrically mounted means, right? On motor shaft, and a spring loaded blade is a spring loaded blade along with a dividing blade. I told to separate the suction side and the discharge side. It is used. It is a very beautifully designed. The center of the shaft coincides with the center of the cylinder. The center of the shaft coincides with the center of the cylinder. Roller is the closest possible contact with the wall of the cylinder. Roller is the closest possible contact with the wall of the cylinder. I hope you understood that point. So roller is making contact, close contact with the cylinder at every time, and the point of contact runs around the cylinder as the shaft and roller rotates. So shaft is rotating, roller is rotating, and the roller is making always make contact with the cylinder at a point. It is a point of contact between the cylinder and the roller. Inlet is separated from an outlet by spring loaded blade, which remains in constant contact with the roller. So I explained this point also. Spring along with the blade. So there is compulsory need of this arrangement of this component to separate the suction side and the discharge side of the port. Next, due to eccentricity between roller and cylinder, the clearance between them is not uniform. Okay, whatever there is an eccentricity present in between the roller, between the roller and the cylinder. So the clearance between them is not uniform. So at every time you can see the gap is changing, the clearance gap is changing. So this is responsible to compress the refrigerant and sends into the next component. So when the space permits, the low pressure refrigerant vapor from the evaporator enters the cylinder. Okay, it means when the space is opened, it means when some gap is provided at the suction port, the low pressure refrigerant vapor enters into the cylinder here. Next, so as the roller rotates, the refrigerant vapor is compressed until its pressure force opens the discharge valve. So this whatever the pressure inbuilt in the side here in the cylinder, that is sending through the discharge port. Here there is a valve is present here, discharge valve. So this pressure is responsible to operate the discharge valve, and it will try to open the valve itself with the help of this pressure inbuilt in the cylinder. High pressure vapor flows towards the condenser. Next, okay, so hope you have understood that roller type rotary compressor. And next, so for a while you observe the vane type rotary compressor. Just look at the diagram and consider what are the components involved in that. You can see all the things here. So look at the components. There is the same similar case. You can see like a rotary type roller type compressor. So it is a vane type compressor. So there is you can see again the same case. You can see at the center here, whatever at the center, you can see this rotor is connected to the shaft which is provided. There is a shaft at the center which is placed center to the cylinder, and there is a rotor, and to the rotor you can see some rotor slots are provided at the four sides: 1 slot, 2 slot, 3 slot, and 4 slots. 4 slots are provided, and this rotation is making here. So there is a rotor slot, and the rotor valve is also present. You can see the crossed sections in this rectangular type of cross section. You can see rotor valves are present, it is making contact with the you can see there is a here around that you can see a cylinder type of structure. A sectioned part is there. To the cylinder this rotor valve is present fixed, and slots are present in the rotor. To the cylinders rotor valves are fixed, and to the rotor slots are provided where the rotor valves are moving inside and outside. Whenever it is making, the rotor is making rotation. And here there is two ports present to the cylinder. Around the cylinder you can see a lubricating oil is present, and at the top it is used for whatever the compressed refrigerant is there, so it will get accumulated at this part, and next it will send it to the condenser. So there are two ports connected here, suction port and discharge port. And next if you see the working part of the, so in this design the motor shaft is set off center with the cylinder and is arranged coaxially with the rotor. So coaxially it is arranged with the rotor. So axially it is moving here, so which is rotating around the inside of the cylinder. Now the same the the movement of the rotor can it is rotating, okay. The movement of rotor is rotating around inside the cylinder. So we'll see what is happening during this rotation. So two or more vanes are recessed in slots in the rotor, and these are thrown out by centrifugal force when the rotor rotates. So whatever the vanes are provided here in the slots, so these are blade type of structures. Whatever the rotor walls I have told here, so there are two or more vanes are provided here. So due to the rotation of the this rotor, centrifugal action or centrifugal force, due to the centrifugal force, the these rotor valves or rotor vanes, so it will be thrown outside and inside whenever this it is making rotational motion or centrifugal force, due to centrifugal force when the rotor rotates. Now the vanes move in and out of the slots in the rotor and make effective contact with the cylinder. Hope you understood that. So whenever it is making it is rotating, so it is moving here and there, so it is making the like the rotor, whatever the vanes are there, they are moving inside the slots of the rotor and coming outside during its rotation like this, okay. Whenever it is making contact with the cylinder, the complete vane is making contact with the rotor. It means in the slot it is moving inside completely when it is making contact with the cylinder, and here the rotor is coming complete contact with the cylinder at one point. So now what happens, in the slot the complete vane is present here. Just similar case at the four sides, whenever it is rotating at close point of contact, the complete slot is filled by the vane. Right. Now the vanes making the contact with the cylinder divide the clearance space between rotor and cylinder into sections. So here there are no need of the spring and the blade here. So it itself these vanes will act like it will separates the sections between the rotor and cylinders, between they are divided into sections. Now here what happens, the suction will take place at one side, compression is acting at other side, compression is taking place at this other side during its rotation. Enables so here the rotation of the rotor enables one of these to expand in size while another is being compressed. Next, the low pressure refrigerant vapor from evaporator enters into the expanding section. So whenever it gets expanded at one side, so gap is provided at the suction side, so low pressure refrigerant enters and it gets compressed in the contacting section as the rotor rotates. So whenever it is making contact with the cylinder by the rotor, so at that side what happens, the less gap is provided, so the refrigerant gets compressed at one side. So compressed refrigerant vapor is forced out at high pressure into the condenser through the discharge valve. This is the case, the compressed refrigerant coming out of the section is sent to the condenser component. So this is regarding the vane type rotary compressor. Hope you understood the topic. Next, small discussion we will make on the screw compressor. If you have the look at the diagram, then you can have the clarity regarding how the compression is taking place here, right? So this is how you can see a front and side view of that. If you see this, the first diagram, there will be a driver and a driven, like male and female components are there. So when they make contact each other and getting rotated, so there will be a one is anti-clockwise and other one will rotate with yeah, a different direction. You can see here. So you can see a driver and driven. uh, you can see here, from the top you can see a suction, and from the bottom you can see a discharge. You can see the side view of that here, suction through a pipe, and what happening here, due to its rotational motion, so it will provide the translatory motion and it will come out other side of the, that is through the discharge side. Now you will see what is happening here. So screw compressors are used in large refrigeration capacities. So that is one application here, when there is a requirement of a large refrigeration, like high capacity refrigeration unit is required. Means like 100 tons, 150 tons of capacity, for example. If you take like that, that is a large refrigeration capacities. So we can employ the compressor type is screw compressors, or you can go for centrifugal compressors like that. So the compressor consists of two helically grooved rotors. So you consider these are the rotors. So it consists of you can see at other side there is a driver, and you can see this side as a driven. You can see the side view of that. So two helically grooved rotors, so one with lobes. You can see lobes are present here around its periphery, just like you can see the lobe is called male rotor. You can see rounded lobes can be seen. That is here is called male rotor. Another way with the gullies is called female rotor. Okay, lobes present on the around male rotor, and gullies is present, is called which is present is called female rotor. Male rotor and female rotors are there, where the male rotor with lobes drives the female rotor. The male rotor with here it will drives the lobes, drives the female rotor in a stationary housing. So as these lobes rotate, the trapped refrigerant vapor is moved circumferentially around the housing of the compressor. Okay, so whenever these lobes are rotating, so whatever the refrigerant present inside that is moved circumferentially. So it means that around whatever the casing is there, so it will move circumferentially around the housing of the compressor. Okay, right. So further, the rotation, what happens due to its rotation, the rotational motion given by these the male and female rotors. So what happens, it will result in decreasing the volume. The volume is reduced. So due to the decrease in the volume in the cavity, it results the compressing the refrigerant vapor. So the volume in cavity is reducing due to the rotation of these driver and driven. Here, due to reduce in the volume, so compression of the refrigerant vapor will take place. So it results in the increase in the pressure. So at a certain point, the discharge port is uncovered. It means it get opened, and the compressed refrigerant, whatever is there, so it is discharged through the discharge valve by further meshing of the lobe and the gully. So to continuation of that, what happens, it will thrown away the refrigerant, which is compressed vapor refrigerant is there, through the discharge valve. So this is regarding uh, the screw compressor. So hope you have understood all these three types, a roller type, and next vane type, and the third one is just as in the screw compressors. So all these three are employed for the refrigeration purpose, depending on the capacity or depending on the usage. For example, if it is used for large type or a smaller type, so depending on that, we can utilize them. And if you go for the centrifugal compressors, so it is these type of compressors are utilized for larger capacity plants. We will see what is the range of capacity for using these centrifugal compressors. just have a look regarding these centrifugal compressors, how they are constructed. You can see the components here. What are the components involved in that? So there is an impeller or a rotor again, you can see. So in the impeller you can see curved vanes are provided here, just like a blade type of structure. Like curved vanes are provided, just like bucket type of structures, vanes in the impeller. And at the center, it is very important, a pipeline is connected, that is the suction is happening at the inlet or eye of the impeller. You are naming it as inlet as eye of the impeller, and around that there is a cylinder, or you can take it as a diffuser, where the refrigerant here it get diffused, which is entered and rotated in the vanes and get diffused in the diffuser. You will see the importance of that. And around the diffuser you can see there is a casing, a volute casing, where you can see the increased cross section at the starting of that, at the top you can see it is starting, and how the refrigerant is moving inside the section. You can see here the increased cross section of the pipeline, you can see of the volute casing. So inlet is at the center, outlet is at the top. You can see at the outlet is more here. Right. Next, so ultimate aim is to increase the pressure of that. So what happens, more the cross section means the more the pressure you can obtain here. So we can reduce the kinetic energy of that, and it means the velocity can be reduced, and more uh, the pressure energy can be obtained. So these are the components included in the centrifugal compressor. So inlet or eye of the impeller, and a curved vanes, a diffuser will be there, and a volute casing will be there. There is a inlet and outlet, inlet at the center, outlet at the out section. Now we will see a small explanation regarding this centrifugal compressor. Okay. Now you see the capacity here, for large capacities it can be used. So in the range, please try to remember that about 35 to 10,000 ton, it's a 1000 up to 35 to 1000 ton capacity it can be used. And for the refrigerant vapor from evaporator passes into the channels formed between the blades of the impeller, formed between the blades. So here the point discussed here, whatever the refrigerant vapor coming from the evaporator, so that it enters at the center of the impeller. Whatever the eye of the impeller is there at the center inlet, so it will enters axially. Okay, axially it will enters. There is a pipeline connected here. So the refrigerant vapor is coming through this inlet, and then next it enters into the blades of the impeller. Whatever the blades is there, so that it will enters into the impeller arm. Next, as the impeller is rotating here, it means whenever the impeller is rotating, the blades, the curved vanes will also rotate. The refrigerant vapor is thrown into the diffuser. So due to its rotating action, so or the centrifugal action of that, so it will thrown into the diffuser due to the centrifugal force. Due to its rotation, what happens, due to its action, whatever the particle present or entered through the center, so it will thrown away to the outer sides. That is a centrifugal action or centrifugal force. Due to its rotational action, all the particles which will fall on that section, so it will thrown away to the different part, so that it will falls into the diffuser, where the gap is provided around these vanes. Okay. Next, into the diffuser, the pressure is increased due to decrease in the kinetic energy. What happens in the diffuser? So due to its arrangement, the pressure is increased. Okay. So due to its increased cross section, you can see in the impeller part, where at the blade provided, the kinetic energy reduces, and it results in the increase in the pressure when it falls in the diffuser. And further, in volute casing, the pressure is increased more. Why? Because there is a change in the cross section, you can see here. So due to its movement, what happens when it enters through the different cross section, increased cross section, the pressure further increases in the volute casing. So this is why the volute casing is designed like this, you can observe here. Okay, so this is regarding the centrifugal compressor, how it is getting, how the refrigerant is entering into the inlet portion, to the eye of the impeller, and how the refrigerant is pressurized, how the pressure of the refrigerant is increased and sent into the next components. Okay, so used for larger capacities between 35 to 1000 tons of the capacity. So coming to the end of this video session, just we summarize what you have learned from the starting of that so far. So we have discussed about the different types of rotary compressors, right? Okay, so different types of rotary compressors and their working. So just we have seen why it is named as a rotary compressor, and next we seen the types of rotary compressors, like uh, we have seen a roller type. Roller is used and how they are named like roller type of compressor. We have seen the working of that particular roller compressor. Next we have seen the vane type, how the vanes are used in the rotor, how the vanes are responsible for that, and how they are compressed. We have seen in the vane type compressor. Next we seen the important topic, that is the screw compressor, how the male rotor and female rotors are present there, how they are designed, and how the refrigerant is compressing when the volume is decreased at part, and how they are getting compressed due to its rotational motion. The what happens, it converted to translator motion, and the refrigerant moves from inlet section to the out up to the discharge section. We have seen in these cases. And next, so these are the types: roller type compressor, vane type compressor, and screw compressors. Okay, hope you understood these topics. Next continuation, we are seeing the centrifugal compressor. For very high larger capacities, we are using these centrifugal compressors. Okay, these are the topics we have covered. Next we will focus on the just we will go into the quiz, how much you have understood. So you can solve from this quiz. Just we look at a simple questions regarding this. So here, the leakage of refrigerant is totally prevented in. So this is regarding you can, this point has discussed in the previous video class already. Complete leakage of refrigerant, we have seen different type of compressors depending on the how they are constructed, or how the electric motor and the components are placed, like open type compressors, semi hermetic compressor, and hermetic compressors. Okay, and told what is the hermetic type compressor also. So the answer you can get is a hermetic type. Hermetic means complete sealed type compressor. So a lot of chances of leakages can be rectified in this hermetic type, but it is a completely sealed one. Right. Next question here regarding these centrifugal compressors are used for the capacity of the refrigerating system. So just now we have discussed that what is the capacity. So without the options you can also tell. I will give the options to you. That is 10 to 100 tons, 100 to 200 tons, 35 to 1000 tons, and 5 to 1000 tons. Just you can note the answers: 35 tons to 1000 tons of larger capacity refrigerating systems. Here we are employing the centrifugal compressors. So you can see the answer, it is 35 to 1000 tons. Okay, next. So this is a few questions regarding that. Next, if you see the frequently asked questions, you can read out the question. So describe with a neat sketch construction details and working principle of roller type compressor. So just you remember the diagram, or different diagrams we are seeing for that roller type compressor. 4 different explanation diagrams can be provided there, so you can easily explain what is happening in the roller type compressor. So to explain the construction about all the components, next you have to describe the how the compression is taking place with the help of roller type compressor. That is a working principle. Good. So hope you can, if you listen this video class, so you can easily write the answer for these particular questions, and it is a very frequently asked question. Okay, right. The next question is same the thing, explain the construction details and working principle of the vane type compressor and screw type compressor. Okay, just you can explain. From this video class you can get the answer regarding this vane type and screw type of compressor. And the last very important and frequently asked question, that is regarding the centrifugal compressor. Explain the construction and working of centrifugal compressor with any its stage. Okay, so diagrams are very important in these all these questions, and I can, if you know the diagram perfectly, and you can, if you know the components involved in that, you can write anything in that. So you can write the construction of that particular compressor and working of that particular compressor. The sketch is very important in all these three questions. So these three questions are very important, and anyone can be asked from these frequently asked questions. So they may be repeated in the examinations. So kindly note these questions. Then you can answer from, you can, if you want the answer, you can go through this video session. Okay, and okay, so coming to the end of this session, so thank you very much for watching this video, and hope you have got regarding the additional information regarding the types of compressors when you compare with the previous video class. So we have focused on only the reciprocating compressor, the construction, and what is the working principle. And in this video lesson we have seen the further topics like roller type, the types of them, like a roller, rotor, like a roller type, vane type, screw type, centrifugal compressors. Seen some quiz part and seen some frequently asked questions. So you can note them down. And so end of this session, I want to tell that kindly next you watch the next video sessions. So continuation of these, we will see the further topics like you can end these one component only we have discussed till now, that is regarding the compressors, the type of compressors. Just we discussed them, taking some important topics regarding in the compressors. The next we will focus on the condenser, types of condensers, expansion devices, what are the different expansion devices, and next we will see the evaporators, what are the different types of evaporators. So we will see the one by one device, and the different types. Different diagrams are very important in this refrigeration equipment topic. So we'll see the different diagrams also. So you can, these are very important diagrams. You can note directly I'm displaying that, so you can take it down as a reference. And so you can, we hope we will see in the next video session. So regarding all these topics, you can watch it down. So hope you have understood all these topics, and we will meet in the next video session. So thanks for watching, and meet in the next video session. So okay, thank you.